digital 12 and the CSK to digital pin 13. The reason as to why they're digital, they'll return every single data in the SD module card or in the RTS. So generally they communicate to the Arduino. They read the program, they read the commands. What are the commands? How do they return the commands? Yes. So we have interfacing a PMS 5003, which is a PM2.5 air quality sensor with Arduino. A plant tower. Most people, they call it a plant tower. It's very common. Like most all the sensors have plant tower. I'm sure, Steve, you have one. Solomon, you have one. You can observe plant tower. Behind, you'll find a semicircular portions, which are well concentrated in one area. And then you have 4 pins. And then we are going to check how it really works. We check on the mechanism which has been built with. Very fast. And then we have, this is the layout of the pins. These are the pins of the plant tower. We have all the times, every single accessory that you're putting into Arduino or into any PCB board, you need to power that accessory. There's the VCC, which is the positive power, which is 5 volts. And if you can check whatever we have here, all this entirely is Arduino. We have PM 1.0, we have PM 2.5, we have PM 10, we have temperature, we have humidity, we have pressure and altitude. And the BME 280, it's externally because it should capture the temperature. So those are the pins whereby you need to understand the way how they work. So what is the mechanism? How does it work, the plant tower? So this is the sensor. We decided to check the layout on how it receives hair and how it analyzes the hair that most times you use. It has a first stage, it has a lesser resource, and then it transfers to air channel, let's scattering measurements cavity, and then it has to go out. And then additionally, there's some electric signals whereby there's a filter amplifier, and then there's a microprocessor. Ideally, plant tower is good for PM 2.5. PM 10, it's not 100% used in measurements in PM 10. I'd say it's about 30% correct. So it has a doubt on PM 10. So this is internally what you have, the blue plant tower. Internally, this is the 4 holes that you can see slightly. This is how the hair flows inside the laser, and this is the fan to cool the system to make sure hair is circulating well inside the plant tower, and it's not clogging. It does not clog. It cannot clog any dust because there's a fan which is having a good suction of hair circulating here, analyzing the data, and sending back the signal and the communication back. So this is the connection of the plant tower and the Arduino. And we have a very essential key stages whereby we have the VCC, we have the grounding, we have RxD, and we have the TXD. All these two are communication to the Arduino. All these two are just power. We are going to do that power, and we're going to check on how they are behaving and their response to the device. Most times, whenever you interface all these, both of them, and you energize the plant tower through the Arduino, you have to give it at least a maximum or a minimum of 5 volts, and the grounding, and then you have to give them a return communication and incoming communication of the data. So globally, plant tower has been used. Purple layer has been providing very credible data on PM 2.5, and most people who have used Arduino have used Purple layer. I'm sure you know it has a very nice data which has a companion of 2 plant towers. It has internally SD module card. It has a BME sensor for temperature, humidity, and altitude. And it also has a PCB board, which is a ESP12, which transmits data to the cloud, and you can as well harvest data through an SD module. So this is a project, but I just decided to transfer the project inside the container, and this is it. And we are going to transfer that data with you and make sure you have it and you can see the flow, how it works. Maybe I have another PCB board inside this place. Maybe it's generating the PM 2.5, and maybe I'm giving you information that you feel you need strong answers on how Arduino works. So that is the circuit, and we are going to check on the circuit how it really works. Interfacing BME with Arduino. What is the functions of BME? BME 280 is an environmental sensor that combines temperature sensor, humidity sensor, and barometer in one board. It has high precision, multiple functions, small size, etc., and the sensor offers plus 0.5 degrees. I want to check if I have some. I share with you guys. I think I do have about 5. BME 280 is a very common sensor and a very essential sensor. It's very precise. You can share equally. You can give them one to share with the group which is close to them. So that is BME 280. It measures very good temperature and humidity without any doubt, and the pressure and the altitude. So depending on the board that you use, if it's an ESP32 or it's a ESP8266, it will give you the same measurements. So these are the parts of the BME 280. It has a provisional of power. It has a provisional of power, provisional of grounding, and provisional of sending data and receiving data. So do not use this. In the market, you are going to find a similar BME, but the best BME that you can get, it's what we just provided. It's a Bosch BME, and it's very affordable. Locally, you can get it with $2 or $1 every pair, and it's very affordable and very accessible. So do not try to get such kind of BMEs. If you open a sensor for Purple layer, they have tried to use the same Bosch company, which I just provided here. So what are the applications and the features on BME? Most of them we've talked about. The temperature, humidity, the range, and the supply of voltage, which is 12C SPI. And the applications is for home automation, health monitoring, which is why we are here, and GPS enhancing and outdoor navigation, weather forecast, and vertical velocity rise and sink speed, which is very important. So this is the circuit flow pinout for BME. You'll find the BME that I've given you. You're going to power probably right now after the session. There's the VCC, and we have the grounding, which goes to the grounding. the SDA goes to F4, the SCL goes to F5. I give you the initial meanings for these abbreviations because it's very important you have them whenever you're working. So this is the circuit flow of the BME. It only needs 4 cables, very easy to connect, very fast to connect. So we are going to do this project. This is a potentiometer, 10K. This is an Arduino Uno R3. And then this is an LCD 20x4. So it's very important you identify what are you going to use in Arduino. What are the accessories which have the availability of the libraries inside the IDE. Most times and every single time, IDE provides the best libraries for Arduino. So for this project, we're going to go through it. I'm sure they have some few pieces. We will go through it and see how the connection comes through. You can try and choose these connections, or there's a back entry circuit which is not very efficiently. So I wouldn't advise you guys to use it. So these are ideally the digital communication, and these are the digital recording or display for the LCD. So the BME uses 5 volts and it shares with the LCD to power. Interfacing DS1302 real-time clock module with Arduino board. This is a real-time clock calendar, which gives you, sometimes you will collect data and you'll find that data does not have, it has date, it's not the actual date. It has time, it's not the actual time that you've been collecting that data. This is the real-time clock, all of you have it. It has a small battery. You have it in your containers. So the real-time clock has a battery, which is a backup, whereby if you don't have the battery, any time that you lose power flow in the sensor, you will find you are collecting data. We're in 2024, but you are getting a data of 1993. So you'll feel that data is not valid because it does not have the battery, and you had a power outage, and the power flow and the circuit flow is not complete. It is very important. We have so many modules, RTS, real-time clock calendar. We have DS3231. We also have DS1302. All of them work equally. Ensure that whenever you use this RTS, it has a good battery, which is working in good condition. So those are the parts of RTS, real-time clock calendar. So this is how you interface. This is how you interface the RTS. So it's the same with other modules. It's equally the same the way how you use the other modules. It has a grounding. It has a grounding. It has a power supply. It has a incoming data. It has outgoing data. All these equipments need to communicate to each other. So this is the connection output and the input for the RTS. This is the RTS module, and this is the Arduino board. So these are the provisions circuit flow that you really need to match them, and you just only need a very small cable, which is